Okay, so on Mercury then, I gave you a bit of a introduction to some of its properties there, but a few specific things that we'll look at, just three in particular. One, we'd like to look at Mercury's composition, so what is it made out of? Number two, we'd like to sort of discuss its magnetic field situation. As we said in the introduction to talk about the planets, that's something that's sort of important planet-to-planet wise. And then the last thing that we'll talk about is Mercury's orbit, its rotation speed, and some things about its timing, which are actually kind of the most interesting things about it. But okay, let's start in this video with its composition. Okay, so Mercury's composition. So here's what happened. You want to study a planet, and so what NASA did way back in the 1970s, I believe, is they sent a space probe in it called Mariner 10. Mariner 10. So I just usually draw these space probes in sort of a generic way like this here. Typically what I'm drawing here is what you see. These space probes are often solar paneled solar powered for obvious reasons. Here's a solar panel and here's a solar panel. I'm just sort of trying to draw here. Not doing a great job of it. You can do a Wikipedia search for it if you want. And maybe this red part is the core satellite, all the computers and the sensors and things. So anyway, what they did is they sent a space probe Mariner 10 up to Mercury, and it made about 5 or 6 orbits or so, and then it was gone. But here's what they did. They wanted to know what the composition of Mercury is, and what they did is absolutely fascinating, I think. They know that the force of gravity is sort of like m1, m2 over d squared. We've done this a few times when we spoke about gravity. Again, if you have any two masses here and here and some distance between them, this will be the force that gets generated. So what they did now is, because they're so close to Mercury now, Mariner 10 got so close to it, they could measure this force. And so I'll sort of write it this way. I'll say maybe in some color here. So force, they measured that, and that would be proportional then. So instead of just m1 and m2, let's be more specific. It'll be the mass of Mariner 10, so that's what the subscript means there, times the mass of Mercury, and all that would be over d squared. Okay, so let's just look carefully at these variables here. Just the law of gravity. This they measured. How? Oh, well, there's a lot of ways, but suffice to say that, say, this little orange unit on here on Mariner 10 was a force probe, something like that. Some of you may have used one of these in your lower division physics or physical science lab, but it's possible to make sensors that measure force. So they just got really close to Mariner 10 and they measured the force. They also knew the orbital distance of Mariner 10, so they knew this. So I'll put a little happy face there and a little happy face there. So they know the force, they know the distance. And they also, since they built Mariner 10, they knew what its mass was. And so this is also known here. Okay? So now you think about it. Look at this formula here. Look at this formula and think algebraically. If you know this, and you know this, and you know this, what can you solve for? Well, it turns out it is possible then to solve for the mass of Mercury. I mean, you could just get some big number for it. You could figure out the mass of Mercury using the law of gravitation. Again, you know d, because that's how far Mariner 10 was from the planet. You know the mass of Mariner, and you have a force probe on there, which is measuring how strongly Mercury's gravity is pulling on the space probe. And so you know all these variables, so you can solve for the mass of Mercury. And they weren't so interested in the mass of it itself, but what they were interested in was the density of it. And of course, you need the mass to do that. So what they did then is, let's just say they figure out the density, because the density then would be the mass of Mercury divided by its volume, because that's what density is, mass over volume. You remember that again from your physical science class, where you might have had like a test tube like this with some water in it, and if you dunked like a piece of aluminum or something in there, you could measure the density of it based on how much the water level rose and so on. You might remember doing that. That's where density comes from. So what did they find out then for Mercury and this density bit when they calculated the density? The volume of Mercury wasn't hard to calculate, because from that they just sort of need the size of it. And if any of you remember, does anyone know the volume of a sphere? The formula for the volume of a sphere, anyone? Going once, but going twice? Well, it's 4/3 pi r cubed. And so this parameter here is the radius of Mercury. And I'm not exactly sure how they did that, but I think the radius of Mercury can actually be estimated from the ground using telescopes and things. And so anyway, this was delivered from Mariner 10, the space probe. The volume, which comes from the famous formula, 4/3 pi r cubed, involving the radius of Mercury, was not hard to find. So the bottom line is they found the density of Mercury. And what they got for the number then, the density of Mercury, was this number here. They got 5,430. 5,430. They got kilograms in every cubic meter. So what that means then is for Mercury that if you have a cube like this, and the cube then is 1 meter on a side, so 1 meter here, 1 meter here, and 1 meter here, 1 meter on the side, it turns out that the amount of stuff that Mercury packs into this 1 meter here is 5,430 kilograms. That's the way Mercury, that's the structure of Mercury, that's the composition of Mercury. Okay, interpreting the number in the next video.